NASA has spotted mysterious spiderwebs on a never-before-explored region near the equator of Mars. The agency's Curiosity rover has been dispatched to probe these bizarre structures, which cover a 6 to 12-mile stretch of Martian desert, as the machine searches for signs that this long, desolate world once supported alien life. Geologists suspect that the spiderwebs are a gigantic version of a type of crystallized minerals known as a boxwork that appear inside some caves on Earth. Some of America's most spiderweb-like boxwork can be seen on the ceiling of Wind Cave in North Dakota. Its web-like shapes are created as calcium carbonate mineral water seeps into cracks between softer rocks, hardens into crystals, and remains as webbed latticework as those other rocks erode over time. But the sprawling, over 3,800-acre wide boxwork on Mars differs in that it was likely formed by Martian seawater and may have trapped fossils of ancient life in its web. These ridges will include minerals that crystallized underground, where it would have been warmer. Early Earth microbes could have survived in a similar environment, Dr. Seebach explained, making the salty liquid water that created these Martian webs an ideal location to find lingering fossil evidence of ancient alien microbes. The discovery comes as Australian researchers have found that a Martian meteorite, which crashed into northwest Africa, provides more evidence of hot water on Mars. A chemical analysis of that meteorite suggests conditions were ripe for aquatic life to develop on Earth's nearest neighbor over 4 billion years ago. Ever since it first parachuted down to the Martian surface on August 6, 2012, Curiosity has been exploring the red planet for signs of life, as well as hunting for clues about Mars' climate, geology, and where all its ancient water went. But NASA researchers have been intrigued by the massive geological spiderweb for even longer, ever since their Mars Reconnaissance Orbiter satellite first captured aerial images of this haunting landscape back on December 10, 2006. How such formations could appear on Mars's surface is still a mystery, but theories point to the climate chaos that stripped Mars of its water billions of years ago. The likelihood that evidence of aquatic microbial life of Mars might be caught in this giant web as fossils makes this an exciting place to explore, Dr. Seebach noted. This web of potential dead alien microbes and bugs rests in the shadow of a 3-mile-tall mountain officially known as Eolismon, but nicknamed Mount Sharp. Past exploration by the Curiosity rover has revealed sedimentary layers along the cliff faces of Mount Sharp in rich detail, suggested it had been formed by water erosion via ancient lake deposits. NASA scientists suspect that this erosion helped form the giant crystal spiderweb, as mineral-rich pulses of water seeped and cascaded down Mount Sharp into fractures in the surface rock and then crystallized. According to satellite mapping work that Dr. Seebach published in 2014, at least 113.6 billion gallons of salty, warm, mineral-laden water would have been required to create the vast field of crystal webbing, which is about as big as Los Angeles Airport, LAX. Dr. Kirsten Seebach, VO, this is a significant amount of groundwater that must have been present. Mineralization, the kind of crystal formation that likely occurred here, is known on Earth to help facilitate preservation of once habitable environments. And in Australia this month, scientists working with Martian meteor NWA 7034, which was discovered after it crashed into northwest Africa, have found further evidence that ancient warm oceans on Mars could have easily supported alien life. Dr. Aaron Cavosi, we used nanoscale geochemistry to detect elemental evidence of hot water on Mars 4.45 billion years ago. Geochemical markers of water were discovered on meteor NWA 7034, based both on the shape of its rocky grain patterns and its chemical composition, telltale signs of water-rich fluids from when the grain formed. It's believed that NWA 7034 was ejected from an asteroid impact on Mars that created a crater in the northeast of the Terra Cimmeria Cyrenum province in the southern hemisphere of Mars. A special technique used to date the age of incredibly old zircon minerals via their trace amounts of radioactive material, called uranium-lead dating, found that this meteor was made up of some of the oldest Martian volcanic rock ever obtained. Dr. Aaron Cavosi, the team identified element patterns in this unique zircon, including iron, aluminum, yttrium, and sodium. This mixture of hot and mineral-rich water, not unlike the hydrothermal vents that support life deep in Earth's oceans, points toward the possibility that life was developing on Mars billions of years ago, amid all this volcanic activity. Dr. Aaron Cavosi, VO. Hydrothermal systems were essential for the development of life on Earth, and our findings suggest Mars also had water, a key ingredient for habitable environments during the earliest history of crust formation. The Australian planetary scientist and his team at Curtin University in Australia published their results in the journal Science Advances this past Friday. Curiosity will begin studying the Spiderweb ridges up close in 2025, according to NASA Administrator Bill Nelson, where it will stay for a month-long journey through Mars boxwork.